Okay, so we have, if you guys would hold them like a bouquet and just hold them up in the air. It was very, very nice. You guys actually, in what you did, you're such good fellow classmates. There we go. Very, very nice. Okay, I got a question. I have a question for them and for you guys. On average, how many lollipops do these 10 people have? Now, here's what you can't do. You can't add up all the lollipops that you all have. You're not allowed to do that. Can't do that. None of you can. Nobody's allowed to add up the lollipops that is. So we're have a big bunch, Blake has 0. We can't go down the line and add them all up, because what are you going to try to do? Divide. Divide it by 10, right? Of course, you're going to try to add them up, divide by 10, because that's how you were taught to do an average. But the thing is why do you do that? That's the question I have, is why do you do that when you calculate that average? Linda, go ahead.
It evenly balances.
It evenly balances it out. Okay, so if I needed to know what the average number of lollipops were amongst you guys without using the formula, how could you do it up there? No idea. That's good too. Let's think about it.
I would guess.
You would get, let's guess.
3.
2.5, 3, 2, 2.6,
2.5.
2.5.
Average.
You guys over here are quiet. It's okay to be quiet. Any guesses?
1.7.
1.7. Let me ask a question. Can I go with 1.7?
Why?
Can I go with 1.7? What would the 1.7 mean if it were 1.7?
If 5 people have more than 1.75 people have.
Ooh! Ooh, I like that. He said that would mean that half of you have more than 1.7 and half of you have less. Thank you, Tom. And that would go for any number, right? If the average were 3, maybe half would have more, half would have less. So what would that imply if it's...
That gives us some ideas for guessing then.
Doesn't it, right? Doesn't it? Yeah, that's a slick way. I like that very much, actually. And that is a perfectly legitimate definition of a type of average. I love it. Thank you, Tom. So could we use that idea
To guess.
to better to guess? Can we do something? Now, you guys can mingle with each other. You guys can mingle with each other to figure out this average value, but you're still not allowed. Go ahead, Tom. Do what you're going to do. You already started doing it. And so did Candace when she gave Blake. All right? So Candace, why did you give Blake some lollipops?
I didn't give it.
Oh, who gave Blake lollipops? He had 2. Wait, Jay, why did you give Blake some lollipops? Because he didn't have any. So what did you try to do, Jay?
Even it out.
You tried to even it out. You tried to even it out. Maybe you should all try to even it out.
Even it out number.
Now you guys here, think about how this ties into what Tom said about half above, half below. What they're trying to do right now is, yes, they're trying to smooth out that half above, half below and spread it evenly across the entire group. Very nice.
Oh.
3.
I got 3.
How many do you have? 3. You have 3.
You still got 2? Everyone has 3 except we got 2 right here.
Oh, look in the bag. One must have fallen out. There should be exactly 30. One might be in my backpack. There should have been 30. That's possible too. There should be 3 per. There should be 3 per. One of them must be in the bottom of my little messenger bag there. Yeah, we'll put the markers on. There we go. So the idea, chew on that, right? The idea is, once we evenly distribute, we take that half above, half below and kind of eradicate that and equally distribute. Then we have an average of 3 lollipops per. So what does an average of 3 mean across a data set? What does it mean again?
The half or above.
Half or, well, at this point, everybody's at. But we ignore the half or above, half or below by spreading all the data evenly, equitably, something like that. Maybe not equitably, evenly. So that's the idea. If you had the same number of data points that you had originally, but you spread them all out equitably, evenly, you'd all have the same number. So when the average number of children in 1990 was 2.5 per family, if you took the number of kids in America at that point and spread them out evenly, each family would have exactly 2.5, which is silly, but mathematical, right? Now do you understand why the formula that you've been using for so long works? Why do you add everything up? Why do you add everything up? So you know what you've got. Why do you divide it by, in this case, 10? To spread it evenly. That's the whole point of division, right? Not much math, a little bit of math. You divide it by 10 to figure out, oh, that means 3 divides evenly into 30 10 times. Give each person 3 and everybody gets the same number of lollipops.
12 years of schooling and I finally learned it.
But that's the thing. You learn the formula very quickly with maybe a brief introduction as to why it works. But until you actually do this, it's like, oh yeah, that makes
10 years
sense.
of
That makes sense.
$20,000 later.
Let's take 5. Okay, let's go ahead.
I just wanted him to explain, because I can't put my finger on grasping how he knew that half of us, if I was guessing 1.7, how half of us would have, under 1.7, half of us would have over. I can't.
Go ahead, Tom.
grasp
But
it.
it doesn't actually work entirely.
In every case.
Not in every case.
in every case it doesn't
Somebody
work.
could have 29, right? Somebody could, and the rest could have 0 or 1, right? So it wouldn't have to be 1 and 9.
But where did that 1.7 derive from?
Oh, I was asking for guesses in that case.
It was guess, but I'm just saying, why, how did he, I don't get where he got that.
I'll tell you what.
Physics 201, like so when you...
Oh, Bruce.
Right, so you draw the thing and where you were to cut it out.
What kind of shape did you just draw?
It doesn't matter, wherever it balances. is-
If it can be balanced in the center, what Tom said is always true. The problem is, the way I laid those pops out on the desk, they wouldn't balance in the center. It's a skewed distribution. Give me, within the next hour, we'll address this. No, Candace, no, Candace, we want to worry about it, but we can't address it in 30 seconds. Let's go
Okay.
through it in the next
Okay.
hour together, okay?
Okay, here.
But take 5, yes, take 5. Grab sugar if you need it. Grab sugar.